Hello guys, welcome back to my YouTube channel. So I'm Archana, I'm of Venkateshwara College of Engineering doing my graduation in HM of EC domain. So today I came with the topic of distributed dual layer self-protection of 5G 6G IoT networks, which is my technical seminar topic. So how it will be let me just discuss in briefly. So how it will be actually is protected from any attackers or any interrupters that will be flowing in while during the message or any data or the information or anything will be just passing from one end to the another end, how it has been attacked by the attackers and how it can be protected from these attackers, that we'll be just discussing here briefly. And my guide name is under the guidance of Vinith Kumar PK and presented by Archana M. Coming to the contents, I'm going to cover up the title, introduction, history of the technology, methodology, objectives, architecture, results, application, conclusion, references. So my topic is distributed dual layer self-protection of 5G or 6G IoT networks. So what is actually meant by it? Okay. A distributed dual layer self-protection 5G 6G IoT network is a cutting-edge network design that aims to secure Internet of Things devices within advanced 5G and upcoming 6G networks. It involves spreading network components across multiple locations, implementing security measures at both network and the device levels, deploying automated self-protection mechanism, leveraging the capabilities of 5G or 6G infrastructure, and integrating the IoT devices securely. The goal is to create a resilient and secure network infrastructure capable of supporting the next generation of IoT applications while effectively mitigating cybersecurity threats. So the introduction part. Increased IoT device usage and DDoS vulnerability. The proliferation of IoT devices heightens susceptibility of DDoS attacks due to their sheer number and varied vulnerabilities. So the challenge introduced by 5G or 6G networks are the softwareization and virtualization of 5G or 6G networks bring forth novel security hurdles complicating defense mechanism against cyber threats. Rising deployment cost of 5G or 6G infrastructure. Deploying 5G or 6G infrastructure entails significant cost which may escalate by considerable margin posing financial challenges to network implementation. Then the composition of 5G 6G systems. 5G 6G network comprises several layers including IoT, radio access like RAN, edge and core, each serving distinct functions in network architecture. And the proposed solution are distributed dual cognitive dual loop system. A proposed implementing a distributed dual layer cognitive dual loop system designed to automate the DDoS attacks in multiple stakeholder multi-tenant 5G or 6G infrastructure. And contribution of the research are the contribution of the research including design proliferation, validating the proposed mitigation system to effectively combat DDoS threats in 5G or 6G networks. Then the history part. So as we know that the history of the technology has been since from our past years, so I guess about 100 years or something like that. So let us briefly what are the history of this major topic which we are studying is the distributed dual layer. What are the history of these topics? Let us just brief it out. So the traditional networking, as we know that the evolution of the networking technology from traditional models to more advanced system led the foundation of modern communication infrastructure. As I already told, the what are the things that we are actually using by using this technology? It has been like traditionally given from the past ancestors. So that is the one point, and the next point will be of the integration of IoT with 5G and beyond. The integration of Internet of Things with 5G or the 5th gen and beyond technology marked in as a significant advancement in communication capabilities. And the one more point is the integration facilitated massive machine type communication (MMTC) on large scale, enabling various applications across different domain aims. As I already told, when we integrate the IoT with the 5G, it will give an n number of applications or n number of enhancements or ensure or any advantages it may give. So the major use of the IoT in the 5th gen is the technology or for the communication in a safe and secure manner. So that is the main mode of the IoT and IoT which has been IoT networks. That's all. And then the cybersecurity challenges, as we already facing the cybersecurity or the any like attackers would be just getting know about our own details or any information without our knowledge itself. So it is better to be safe than the prediction, right? So the first point of the cybersecurity challenges are the sheer number of devices involved in IoT ecosystem made manual cybersecurity management impractical of large-scale scenarios. So the next point will be as IoT network expanded and became more complex, managing cybersecurity became increasingly challenges. As I already told, so as the IoT network has been expanding more and more in the day by day like a scenario. So the large scenarios has been facing, and also the cybersecurity need to be even implemented in all the devices or all the IoT networks as well. Why? Because the cybersecurity will actually just help us to be safe and protected from all other attackers. So that is the main thing of the cybersecurity challenges. And the cybersecurity challenges are facing like nothing but like there are large number of IoT expanded like IoT networks or any IoT devices, communication protocols are just expanded in a various form. So it is best to give all the IoT networks with a cybersecurity protection. That's all. And then the emergence of closed loop automation loops, like this point is nothing but what we had already like we are using this closed loop automation loops as one of the major important role in these technical seminars. So that is why it has been explained over here. And in response to growing complexity of cybersecurity management, excuse me, in response to the growing complexity of cybersecurity management, closed automation loops begin to emerge as essential tools. These closed loops automate the cybersecurity management process, enabling efficient threat detection, analysis, and mitigation. So the next point will be shift towards advanced cybersecurity solution, which is actually made required at this currently technologies. The need of more advanced cybersecurity solutions became apparent to one minute. Okay, the need of more advanced cybersecurity solutions became apparent to address the evolving threat landscape targeting IoT networks. The abstract suggests a shift towards cognitive closed loop system to offer distributed dual layer protection against distributed denial of service attack, which is known as DDoS attacks in IoT environments. Coming to the methodology part, as we can see that the encapsulation of traffic isolation. So which are the steps which has been we are using for just designing or developing or implementing this like now self protection thing has been briefly discussed here. So the first methodology or the first step that we need to take is encapsulation of traffic isolation. So different stakeholders in 5G or 6G system required varied approaches to manage data flow within their infrastructure. Encapsulation mechanism like virtual extensive LAN are used for multi-tenancy, ensuring traffic isolation of each end. So the which are the traffic which we are facing in the today's gen or which are the networks are facing. So it will be just isolated by using this by the name of traffic and like a traffic isolation, and by using the encapsulation mechanism like virtual extensive line, like we like the traffic occurs because there is no path or because there is no space to pass the signal. So it is better to expand the path, right? So the major mechanism that the encapsulation is that the encapsulation is nothing but adding some more things to anything. So here the path is been adding with some more path for the non like isolating the traffic. So these what is that encapsulation mechanisms have been used, like example the virtual extensive of LAN. So the LAN local area network which has been expanded by using the encapsulation mechanism. That is one of the point. And then coming to the architecture overview, the 5G IoT network architecture involves IoT devices communicating with radio access network, which mean which then routes traffic to hedging computing infrastructure. Encapsulation protocols like CPRI and GTP are utilized for effective data routing. So the architecture, what are the things that has been included, that has been explained over here, and which need to be included, that is also explained here. And the role of DSPs and ISPs are the DSPs equip the virtualized central units VCUs and multi-access edge computing MEC capabilities. Handle higher function of a non-real-time data. ISP manage traffic routing and encapsulation process Traffic leaving the DSP in encapsulation in GTP passing through the ISP's network at the ISP edge VXLAN encapsulation ensuring tent isolation. So this is the flow diagram that has already told. These are the devices which are been which we are using, and then the wireless communication. This indicates the dotted lines as it is already mentioned here. These are the wireless communication from the device, and then it is go to the 5G like the tower, and then afterwards the DU, the dual layer. It is been going to here, and then it will be a V switch. So the V switch will be just giving the parts to the VCU, which we already discussed as virtual CU, and then it will go into the DSP compute layer, and then DSP edge 1 to edge n. This is like we can see that there is like from edge 1 to edge n, so there are so many of DSP's edge here, and then again it will just coming back here and ISP computer layer and then the DSP edge. And here the central switch will be there for the switching of these things, and the mirror switch will be there for the DSP part. So again this part will be just coming over here, and then it will be given to the interdomain switch, and then the interdomain peering router, so which we are using as an internet thing, and then it will go to the internet part. So these are the different layers, and we can see the complete traffic occurring in the 5G system infrastructure. As in the first part, encapsulation, what I have said. So they had been just given an example of the traffic which has been occurred in the 5G infrastructure. And then the methodology has been continued over here. The security monitoring and mitigation. Traffic is monitored and mirrored by switches or ISP and DSP allocations. Security monitoring agents SMAs analyze traffic for potential threats, triggering alerts when anomalies are detected. So which has been like the security part has been explained over here, and the self protection closed loop closed control loop components. The architecture includes various software components forming a closed loop for self-protection against threats. The components include resource inventory agent, security monitoring agent, analyzer, decision maker, planner, orchestrator, and for flow control agent. So the FCA functionality, FCAs are agents installed on infrastructure computers enabling between physical and virtual machines. These provide distributed mitigation by being multiple the infrastructure and serve APIs like the applications for various control technologies like tablets and so on. So the first objective of the like technical or these topics is to enhance attack detection accuracy. As we know that the detection is very important for any of the technologies or any of the cybersecurity part. So it will be accurately detecting which are the attackers that is been causing the problems or that are being that need to be controlled. And the second point will be to enable autonomous adaptation to dynamic threats. Autonomous adaptation means like for any of the threats or any of the failure. Let us give an example like autonomous threats is the thing, but any dynamic threats or any threats will be occurring, so it should be automatically detected, and it should be updated to the architecture which I already showed, right? So it should be detected over that, and then the cyber security will just the self protection act will be just taken over that particular threats to minimize impact on legitimate traffic. So the traffic which I already saw, the encapsulation need to be done for to first we should isolate the traffic, and then the encapsulation part need to be done. So it will reduce, as I already told, the encapsulation part is already included in the architecture, so it minimizes the traffic for like it is it is being connected from one part to the another part, so the traffic will be reduced to ensure rebootness and reliability. That is normal point. And testing and validation of the architecture, these will be just telling like what are the test procedure and how it could ensure and how the results will be coming. That parts has been discussed over here. And this is the normal architecture. So what are the things that analyzer, decision maker, planner, or orchestrat? So these are the things that has been included over here. So yeah. And the 32 IoT infected devices in a multi-stakeholder collaboration with the self-protection system or core GUI. This is the actual diagram of that. Coming to the results parts, average execution time. So the execution time it is been minimized over here. The second point will be attack detection and mitigation. So what are the attacks that what are the what are the attackers or any threats that can be that will be coming over here, so that it has been attacked and mitigated. The collaborative system of outperforms the standalone system in terms of number of attacks stopped. For instance, with 128 simultaneous attacks, the collaborative system is able to stop 100% of attacks, whereas the standalone system will be only of 15%. So, to demonstrate the benefits of collaboration among stakeholders to in detecting and mitigating attacks effectively. So, next one will be component contribution. Analysis of individual components within the self protection loops reveals that the collaborative system exhibits smoother operation and lower average times of critical components such as the planner, despite the presence of resource saturation. This highlights the efficiency of resource utilization and load balancing with the collaborative framework. Then with system resilience in the scenario with a high number of attackers, example as 256. So these are the graphical results which has been which has been given as an output of the results in the like procure design or the development of the system. So this is the average execution time consumed by the loop. So which we are using the closed control loop. So this is the average time which has been used. So with respect to the execution time and the number of attackers. Okay. So the number of attackers is as I already example as 256. So it has been increased standalone system has been increasing one after the other, but the collaborative system which we are using is been reduced here. So we can see the difference between 18 seconds to 57 seconds. So the average execution time like consumed by the loop is nothing but for any detecting any of the attackers or any of the threats. So the standalone system is actually taking so much of time, but the collaborative system is actually reducing, and also it is taking less time for detecting in the which has been average execution time, that is the execution time is actually very low compared to the standalone system. And here the average number of successfully stopped attacks. So expected stopped attacks, it is one of the points. So we can see the green color is nothing but the standalone system, and the blue one is the ISP, like collaborative. So there are different layers in the blue as well. So one is ISP, next one will be the DSP one, and the next will be the DSP2. So here we can see the difference that the standalone is actually like stop attacks and the number of attacks. So here nothing but how many like based on the 256 attackers, how many the standalone system is been actually reducing or actually stopping the attacks, or which is being protected. That is what the motto of this project, right? So here it has been reduced gradually. We can see that from 26 it has been like reduced to 12, but here the number of stopping those attacks will is been increased. That is one of the difference. And here the same is the average execution time for 256 attackers, the what are like execution time. So the intention time, then the planner time. So yeah, this is the things. And then coming to this thing, the average number of stopped attacks by for 256 attackers. So it is being stopped over here based on the different portals. The things has been stopped over here. That's all. So the major application of these things are deployment in various IoT applications, scalability for large-scale IoT deployment, ensuring robust cybersecurity postures, and integration with stakeholder roles, ensure service delivery. Coming to the conclusion part, the collaborative system demonstrated remarkable effectiveness across various network topologies, exhibiting adaptability to changes and addition of new infected IoT devices while consistently maintaining high rates of detection and mitigation through empirical evidence. It is evident that the proposed solution offers substantial cost reduction and minimized downtime associated with DDoS attacks, achieving response time as low as 20 seconds and thereby mitigating financial losses. Moreover, the simultaneous execution protection loops across different stakeholders creates a naturally multi-layered protection system harnessing distributed resource to bolster security against cybersecurity. The future scope that can be implemented in this development is the future scope of the studies involves leveraging distributed environment to address resource limitation. Okay, and incorporating AI based components for more precise attack analysis. So the AI has been, which is currently running technology, so it can be even implemented or included in this technology, or included in this design, and further improving the performance of the collaborative system to handle large DDoS attacks with the goal of stopping 100% of attacks launched by significant number of infected devices. Yeah. So these are the references which I made to for this technical seminar report, sorry, technical seminar topic. So yeah, I got mainly I just concentrated on the first one. So yeah, these are the actual other like meant for same topic. So I just study about these references, and by these references, I came to one decision that okay, this topic is so and so. Yeah. Yeah, thank you for watching my channel, and keep supporting me. Thank you.